we're working on surface area and volume of prisms and cylinders. So what I did was I broke it down by shape. So first let's focus on the rectangular prism. For surface area of a rectangular prism, imagine that you're wrapping a gift to give to a friend. You would want to cover the entire box. All of that area that you cover is the surface area. So in order to calculate that, all you have to do is find the area of all 6 of the surfaces. So the area of the top and bottom, the area of the front and back, and the area of the left and the right. And then once you have all those areas, you add them all together, and that's your answer for surface area. So let's look at an example here. We have a 9-inch by 3-inch by 4-inch rectangular prism. First, let's find the area of the top and the bottom. So in order to do that, we would multiply 9 times 3. If we look at the top here, I know that you don't immediately see numbers for the length and the width. However, since this length is 9 here, I can assume that this is also 9. And since the width here is 3, I can assume that this is 3. So what I did was I multiplied 9 times 3 and got 27. Now remember, for rectangular prism, if the top is 9 by 3, that means that the bottom is also 9 by 3, so I did the same thing again. Now let's look at the sides. We have 3 times 4, which is 12, and once I do that side, I know that the opposite side is the exact same size, so I once again did 3 times 4 again. And last, for the front and back, we have 9 inches by 4 inches, and even though the 4 is over here, I can assume that this is the same as this. So that would be 9 times 4, which is 36, and since the front is 36, the back is also 36. Now that I have the area of all 6 of the sides, all I need to do is add those all up, and I get 150. Since this was measuring in inches, I made sure to put inches in my answer. And even though we're dealing with a 3-dimensional object here, we're still finding area. Even though it's surface area, it's still area, so our exponent will still be a 2. So it's 150 inches squared. Now for those of you who prefer to use a formula instead of figuring out each side separately, here's your formula that you would use. So if I plug in the numbers as I go, instead of 2 times length times width, I'll do 2 times 9 times 3 plus, and then instead of 2 times width times height, I'll do 2 times 3 times 4 plus, and then instead of 2 times height times length, I'll do 2 times 4 times 9. When you plug all that in, you end up getting the same answer, 150 inches squared, just a different way of doing it. Okay, now for volume. Before we even get into volume of a rectangular prism, you need to understand what volume is. Imagine pouring water into a solid, such as a cylinder. Filling it up to its fullest capacity is known as the volume of the solid. So when you think capacity, think volume. Okay, so now let's understand it in terms of rectangular prism. It says, remember, volume represents capacity, so we must think in 3 dimensions. In the prism above, the length is 6, the width is 2, and the height is 3. In order to find the volume of this prism, all you need to do is multiply all 3 dimensions. So length times width times height. So in this example here, we would multiply 6 times 2 times 3, and that would equal 36. Now if you look at the units that they gave me, it was cubes and rows and layers. They didn't say centimeters or yards or inches or feet. So I just put the generic units, and since we are talking about volume this time, our exponent will be 3. So it's 36 units cubed. Now let's move on to cylinders. First, we'll focus on surface area of a cylinder. In order to get the surface area, we need to get the area of the top, which would be the circle on top. We need to get the area of the bottom, which would also be a circle. And then we need to get the area of all of the sides. So that would be all this, all around it, okay? So the formula for area of the top would be pi r squared. It's just a simple circle. And the same thing for the bottom. And then for the area of the side, you need to use this formula. 2 times pi times r, which is the radius, times h, which is the height. So now let's plug in the numbers that we have here. Instead of radius, I plugged in 3, so pi times 3 squared. I did the same thing for the bottom. And then here it's 2 times pi times the radius, which is 3, times the height, which is 8. When you plug each of these in, and remember you're adding all of this together because for surface area it's taking each of the sides and adding it together, you get 207 3/10 centimeters squared. Plugging that into a formula would look like this. All I did was I consolidated everything. So if you look what we have here, we have pi r squared, we have that twice. So I just multiplied it by 2. 2 times pi r squared plus 2 times pi times the radius times the height. So this right here would be our formula. Again, you would just plug in the numbers into the appropriate places. So instead of the radius, I plugged 3. Same thing here. And instead of the height, I plugged in 8. And you get the same answer, 207 3/10 centimeters squared. And last, let's look at volume of a cylinder. And for volume of a cylinder, all you need to know is the area of the base and the height. So the formula again for area of the base, it's just a circle, so it's pi times radius squared. And the height is obviously just 8. So for us, it would be pi times 3 squared in this example, and the height is 8. And now we use the formula, which is pi times the radius squared times the height. So if I plug in the appropriate pieces, it'll be pi times 3 squared times 8, which equals 226 2/10 centimeters cubed. Notice I use centimeters because that's my units, and since we're talking about volume, it's cubed. That's all for today. Bye, guys.